Hi, welcome back. Today, let us look at how the Linux boot process works. When you press the power button, Linux is not running yet. There is no shell, no services, no login prompt. The machine has to wake itself up through a chain of small handoffs. Firmware starts first. Then a bootloader finds the kernel. The kernel starts the operating system core. Then the init system brings the rest of the machine to life. In this episode, we will follow that chain from power on to login. The first code usually comes from firmware, often UEFI on modern machines. Firmware is built into the system. Its job is not to run Linux. Its job is to wake the hardware enough to continue. It checks that basic devices exist, initializes enough of the system to read from storage, and chooses a boot device. Think of it as the machine asking, "What can I start from?" Next comes the bootloader. On many Linux systems that means grub, though there are other options. The bootloader knows where the Linux kernel image is stored. It may show a menu, let you pick a kernel version, and pass startup options to the kernel. It also usually loads something called an initramfs, a small temporary file system used very early in boot. Then the bootloader hands control to the kernel. Now the Linux kernel is running. This is the point where the system starts becoming Linux in the strict sense. The kernel sets up memory management, starts using CPU features properly, discovers hardware, loads the drivers it needs, and prepares the environment for user space. Early boot messages, the ones you sometimes see flying past on a console, are the kernel describing this discovery process. The initramfs is a temporary world in memory. It exists because the kernel may need help before it can mount the real root file system. For example, the real root disk might be encrypted on RAID, on LVM, or require storage drivers. So this tiny early environment loads what is needed, finds the real root file system, and then switches from the temporary world into the actual installed system. After the real root file system is ready, the kernel starts the first user space process. On many distributions today, that process is systemed, and it gets process ID 1. PID 1 is special because it becomes the parent of the user space service world. Systemed reads unit files, starts required services, handles dependencies, mounts file systems, starts networking when configured, and eventually gets the machine to a usable target. By the time you see a login prompt, a lot has already happened. Firmware woke the machine. The bootloader loaded the kernel. The kernel took control and prepared hardware. The initramfs helped reach the real root file system. Then systems started the user space services. Login is not the start of Linux. It is the point where the boot chain has done enough work to let a human, or another machine, enter. Thank you for watching. Subscribe to get notified when the next part drops.